we're going to take a look at one of the properties of parallelograms, which is that if a quadrilateral is a parallelogram, then the opposite sides are congruent. All right, so this is one of the several properties I have for parallelograms that we can prove that the opposite sides are congruent. Like all of them, for the most part, we are going to use congruent triangles to actually do this. So what I need is, of course, my diagram here. I need a diagram with a parallelogram in it. That's pretty solid. I'll label it. And then my given is just that A, B, C, D is a parallelogram. And then my prove is interesting because my statement says here that if a quadrilateral is a parallelogram, then the opposite sides are congruent. I'm just going to prove one of the pairs, though. And I'm going to do this for all of the properties that I'm working with for parallelograms. And the reason for that is all of these proofs, for the most part, could just be repeated a second time in a different way to prove the other thing. And so in this case, if I can prove A, B, and CD congruent to each other, then I could just prove AD and BC congruent by repeating a similar process. Now in this case, for this situation, it actually would just be one more step, but because I'm doing this all these properties, I'm just going to leave it there. So the way that I'm going to go about doing this is whenever I have a problem like this where there's not a lot of information and I don't know how to break it up, what I'm going to do is turn it to a problem that I already know how to solve, which is triangles. I know a lot about triangles at this point, and so if I can prove some triangles congruent, then I can use that to my advantage. And so I, of course, need some triangles to work with. So what I will do is I will draw in the diagonal here from A to C, and now I've got two triangles to work with. And if I can prove these two triangles congruent to each other, then I'll be well on my way to proving my actual goal. So that is what I'm going to do first. I'm going to draw on that segment, and then we'll work through actually proving these triangles congruent, and thus their corresponding parts will be congruent. So I'll start with my given, which is that ABCD is a parallelogram. And we'll go from there with trying to prove these congruent to each other. So how am I going to prove these triangles congruent? I'm going to need some sides and some angles. I can start with the easy one, which is AC. AC is shared between these two triangles. I can say that it's congruent to itself by the reflexive property. And then from there, I need to use, the only thing I have available to me, which is that ABCD is a parallelogram. And let me mark that real quick. So what do I know about parallelograms? The only thing I really know at this point is that there's a definition, which is that the opposite sides are parallel. So I'm going to have to use that to my advantage. I'm going to make a statement that A, B, and CD are parallel to each other. AB is parallel to CD. And my reason for that will be the definition of a parallelogram. A quadrilateral is a parallelogram if and only if the opposite sides are parallel. The opposite sides are parallel. And that comes from 1, where I said it was a parallelogram. And then I'm going to do the exact same thing for my other pair of sides. So AD is parallel, no, that's congruent, is parallel to BC. And for the exact same reason. And so the question might be, well, where am I going with this? And I have to think all the way back to several theorems ago, where I was using parallel lines to talk about angles. I'm going to use my parallel lines to talk about some congruent angles here so that I can use them then in my congruent triangles. So what those are angles. Well, let's see. So I'll mark these as parallel to each other. So what does this tell me? Well, what I have here are parallel lines and a transversal. And so what I am going to talk about next are these angles that are congruent. These are my alternate interior angles across parallel lines A, B, and C, D. So I can actually talk about two pairs of congruent angles here, but I'll start with these. So the first one is angle BAC. Angle BAC is congruent to angle, let's see, DCA. And that would be because if the lines are parallel, then the alternate interior angles are congruent. And so I just got to be careful with what I cite here. So BAC is on line AB. So I'm going to cite 3 versus the next pair of angles I'm going to talk about. I'm going to cite the other pair of lines. So I'm going to talk about my other pair, which is, let's see, these two right here. So DAC and BCA. So they will be congruent as well. So angle DAC is congruent to angle BCA. And the reason for that will be exactly the same thing. So if the lines are parallel, the alternate interior angles will be congruent. And the reason I'm doing all this is now I have 3 things to work with here, and I can finally talk about my triangles being congruent to each other. That comes from, okay, so this one comes from, all right, so I'm talking about BC and AD this time. So BC and AD was 4. So now I have these. I have my 2 triangles being congruent to each other. And the reason for that is angle, side, angle. So I can say 7. Triangle, let's see, BAC is congruent to triangle, all right, BAC and then DCA, triangle DCA. And the reason for that will be, let's see, angle, side, angle. If the corresponding angle, side, angles of 2 triangles are congruent, then the triangles are congruent. All right, perfect. And that comes from, let's see, what all I need to cite. 2, 5, and 6. And so I did all this work, and I proved these triangles congruent so that I can finally prove the thing that I wanted to, which is that A, B, and C, D are congruent to each other. So that'll be my last statement. Statement number 8, AB is congruent to CD. And the reason for it will be my definition of congruent triangles. 2 triangles are congruent if and only if their corresponding parts, am I gonna run out of room? Corresponding parts are congruent. All right, and that comes from 7. All right, just enough room. So, like all these properties, what I'm doing is I'm turning a problem that I didn't really know how to do before and turning into something I do know how to work with, and that is breaking this up into triangles. So once I was able to divide my parallelogram into 2 triangles, I proved those 2 triangles congruent and then used their corresponding parts to talk about them being congruent. So It's really as simple as that. Not too bad. And so this is just one of the many properties that we'll be talking about with parallelograms.